Hey guys, in this video I'm working on the VRM heatsinks on an MSI Z270 Gaming Pro Carbon motherboard. This board, just like the graphics card you'll see later in this video, came from an old PC that was running for about 8 years and was never serviced. So I took the whole system apart, and the first step for me was to bring the motherboard back into proper condition. What you see here is sped up, of course. In reality, it takes quite a bit more time, but I think this kind of maintenance is absolutely worth it because after replacing the thermal pads on the VRM area and the chipset interface, the board can cool properly again, and I know the power delivery and heat dissipation are where they should be. As you can see, the thermal pads under the VRM heatsinks have degraded over time. They've become soft, oily, completely lost their structure, and at this point they're barely doing their job. So instead of transferring heat, they're basically just sitting there. That's why I replaced them with high-quality gelid thermal pads, 1.5 millimeters thick. They're much more stable, and once they're in place, heat transfer through the heatsinks is back to where it should be, maybe even better than stock. On the chipset, there's a small heatsink with the original factory thermal interface, kind of a sticky material. Over time, it dries out and loses effectiveness, so I remove it, clean and degrease the surface, and instead of thermal paste, I use Thermal Grizzly thermal putty. This type of material is widely used in laptops, where you need to compensate for uneven surfaces and different chip heights, especially around memory and VRM areas. It helps the heatsink sit evenly across the entire surface, which is exactly what I want here for proper heat transfer. You can also see me installing heatsinks on the SSD drives. On the main SSD, the one for the system, I'm using a gelid thermal pad, and on the second, cooler SSD, I'm using a different green pad. It doesn't run hot anyway, so that's more than enough for it. I'm going to use this hardware to build a new gaming PC and see what this setup is actually capable of in 2026. This board originally had an Intel Core i7-7700K installed, and that's exactly what's going to stay in the new build. The idea is to pair it with a 240mm AIO, tune everything properly, maybe push it a bit, and see what this old hardware can really do. I'm going to test games like Cyberpunk 2077, Call of Duty, Delta Force, GTA 4, World of Tanks, Need for Speed, Asphalt Legends, The First Descendant, Fallout New Vegas, maybe even Hogwarts Legacy, just to see how far it can go in a CPU-heavy title. And now it's time to take care of the graphics card, MSI GTX 1070. The design on this one is pretty simple, easy to take apart, easy to put back together. The only thing to watch out for is the fan and RGB connectors. Over time they get brittle, so you have to unplug them very carefully. As expected, the old thermal paste is completely dry and crumbling, so I replace it with Thermal Grizzly Cryonaut. Thermal pads are replaced as well, 1 millimeter on the memory chips, and thicker ones, around 3 millimeters, on the VRM section. Just to give you an idea of the result, you'll see everything in the next video, so make sure to subscribe and drop a like so you don't miss it. As you probably understand, the idea behind this video is pretty simple. I just want to bring this old hardware back to life. I'll try to get the next video out as soon as possible so you can see what this 8-year-old system is still capable of in 2026. If you're into this kind of content, make sure to subscribe and drop a like. I'd really appreciate it. Thanks for watching, and I'll see you in the next video.